What's up guys, you're on the pick of the week. This is Math with Daniel Dallas and I created videos on a weekly basis. I pick up interesting questions and problems from different levels from GCC out to IB, A-level and even university program. Alright, so today I'm going to show you how to work with modulus or nested modulus as well. So modulus, as you remember, is absolute value of some expression. So let's have a look at the function. Y from x is absolute value of x minus another absolute value 2x minus 1. So if you have a look here, you understand that the expression 2x minus 1, which is taken absolutely, that means you're taking the modulus value of 2x minus 1, is nested inside the exterior modulus. So this sort of interior modulus inside exterior. In this case, we have deal with nested modulus. And let's have a look at the question. So try to repause the video, try to do by your own. And let's get started explaining. So you have the graph, you need to graph the following function, y from x, which is equal to absolute of x minus absolute 2x minus 1, nested. Okay? And hence or otherwise you need to solve the equation for x. Let's get started. Before, we need to give definition of what modulus is. So if we know that we take an absolute value from x, this is x by definition. We just simply get rid of absolute values, those parallel lines, if only if x is more or equal to 0. So indeed, if you have, let's say, absolute of 7 is already positive, so that's why just simply 7, because inside expression 7 is more or equal than 0. And then if the x itself is less than 0, so we take in negative x. So simply, for example, if we have negative 6 and we take an absolutely final, we know we need to get the positive value, positive for 0. In this case, we have negative 6, so negative 6 is definitely less than 0, so we have this condition, and that's why we simply need to put minus before the expression, but expression is negative 6, so that's why we put extra minus before, and finally we get 6. So in the end, we still have positive values, all right? So that's how modulus works. Let's get to the next step. So that's why if we equate the expression inside modulus to 0, and this is going to be the point, so actually by solving that we'll get the point that defines behavior of absolute x for two ranges. So on the right side of the splitting point and on the left side of the splitting point. In this case, x equals 0 is the splitting point. So that's why applying this approach to our case, we would like to start from inside or interior modulus expression, which is 2x minus 1. So that's why the first step, we want to get rid of absolute value and find, first of all, the splitting point by simply equating this inside interior expression inside the modulus to 0. So we just write in what stays in the modulus, we equate to 0, from where we get the solution x equals 1 over 2. So hence here it means that the function would look like differently if we consider the right part, for example here, and the left hand part. For example, the right part is the part greater than 1 over 2. So that's why if we consider x more or equal than 1 over 2, this expression will be positive. Indeed, so you can plug any point, let's take 1, we plug x equals 1 inside the value, we'll get inside of x, we'll get 2 minus 1, it's 1. So the expression inside the modulus is positive, so that's why there is no need to keep those parallel lines and we can get rid of them. So that's why when we get rid of those parallel lines from the expression 2x minus 1, we simply get x minus 2x plus 1 because we expand the brackets, so minus goes here and minus goes to negative 1. Finally we get x minus 2x plus 1, okay? Absolutely, because we haven't got rid of the external absolute value. We still have modulus value. And that means on the right side of 1 over 2, great for values x greater than 1 over 2, we'll get new function y1 from x instead of your previous one. The same principle can be applicable to the left-hand side when we have the value for x less than 1 over 2. In this case, y2, a new function appeared, we just simply put the minus before the absolute value just by definition of the modulus. So that's why if we put minus before the expression 2x minus 1, we can get rid of those absolute values, and instead we will get x plus 2x minus 1, and still absolutely. So that's why for two ranges less than 1 over 2 we'll get y2 function, and greater than 1 over 2 we'll get y1 function. As you can see, they're completely different, and now you need to simplify the expression inside modulus. After simplification, you'll get 1 minus x absolutely for the range x greater than 1 over 2, and y2 3x minus 1 if you simplify that. Okay, one more time, just compare. You had x plus 2x minus 1, so 3x minus 1 here, and x minus 2x plus 1 will give you 1 minus x. So that's why finally, after simplification, you'll get two different types of function. And I hope you remember how to work with absolute value. You just simply do the next step. So you remember that absolute x simply behaves as the V shape. So if you plot this graph here, so you'll get something as x here, it behaves like x here, and here below x values, below x equals 0, it behaves like negative x. So applying this principle, you can plot the right graph y1, 1 minus x, on the right of the splitting point and on the left side of the splitting point. By the way, the splitting point here, x equals 1, okay? And here is the same, 3x minus 1, that's another graph. 3x minus 1 you equate to 0, so you can get the splitting point for this graph as 1 over 3. And on the right side and on the left side, 1 over 3, it will behave like V shape. So for example, on the right side, 1 over 3, it will behave like 3x minus 1, and on the left side of 1 over 3, it will behave as negative 3x and plus 1. Here we go. That's already built for y1 function. However, you see a dashed line. We need to build the graph, the V-shaped graph, on the values more or greater than x equals 1 over 2. So that's why those dashed lines we need to exclude, and hence the right graph that has the V shape will be here. Okay. So next part. So by the way, the graph, the vertex of this graph will be at the point x equals 1. In the same manner, we can build 3x minus 1, and as you remember, I mentioned 1 over 3 as a splitting point. So that's why you will have this sort of greenish graph. And again, we need to exclude all the values. We need to erase the graph if we are in the range for x greater than 1 over 2. So that's why after erasing those dashed line, we'll get finally the green part that stays for y2. And finally here, we'll get the following. So that's the complete graph, and after just redrawing more accurately, you'll get y from x as the final function. It looks like two V shapes with different slopes, like the blue one and the green one, and they behave differently. Okay, so now we fix 1 over 3 and 1 as the vertex point of those graphs. That will allow us to solve the equation. So to answer the second part, x minus absolutely 2x minus 1 absolutely, and again absolutely equals to 0. So that's why we clearly see where the function, in other words, where the function y from x equals 0. it equals to 0 exactly here when it crosses the x-axis, and here when x is 1. So both solutions, x1 and x equals 1 over 3, they are both solutions for your modulus equations. Alright, so hope you understand how it works. It's more complicated if you compare it with like just single modulus. Nested modulus always more complicated. However, I give you the instructions how to work with that. So please try to practice more about like trying to graph different absolute values. In this case, both graphs were linear. So what about quadratic? So you can try to also sketch the quadratic function with absolute value x squared minus 2x and minus 3 beyond the modulus. So in the next video, I'll probably show the clue how to do that for quadratic functions. But you can ask any questions in the comments, and maybe if you can solve that, try to give the answer, at least how you can expand for which ranges. It will be useful, guys, for you. And finally, so in the next week, I'll try to show you how to work with quadratic expressions that have also modulus values. All right. So hope you like that. That was Daniel Dallas. Thank you, guys, and see you next week.